Hello everybody, this is Miss Pie. I'm doing this test review for any students that missed class during the review, and if you guys want to watch it again or go through the review again, you can watch this video. Alright, so let's go ahead and get started. We're going to have several different questions on the test, and one of them will be similar to this. So we just have an equation, or we just have an angle in radians, and we need to convert it into degrees. And hopefully you guys remember that the formula to do that is you take your angle in radians and you're going to multiply it by 180 degrees and divide it by pi. And when you do that, you can, of course, the whole point is to get as accurate answers as possible. So you can cancel out the pi's, and the 9 will reduce that 180 to what, 20, right? And then all you have to do is multiply the 11 times 20 and you get 220 degrees. Okay, so hopefully this one's a fairly easy one. Hopefully you guys remember that the formula to do this is you take your radians, multiply it by 180, divided by pi. Alright, now you might also get a question like this where you have degrees and you have to convert it to radians, and you need to make sure to give the exact answer, so no decimals on this one. Okay, and very similar to this problem here, we're going to take our angle, and this time it's in degrees, and this time instead of multiplying it by 180 over pi, we're going to do the reciprocal. We're multiplying it by pi and dividing by 180. And I've told you guys many times that in your calculator, when you do this calculation, let me pull up a calculation screen, you're going to totally ignore the pi. Okay, so we had 240 degrees times pi divided by 180. So for now we're going to ignore pi and we're just going to do 240 divided by 180. And we push enter, and the calculator gives us this fraction 4 over 3. And yes, I know we could push control enter and get around a decimal or a decimal answer. I don't want this. It's a terrible answer, so I'm just going to delete it. If I can, let me see. Nope, it won't let me delete it. Anyway, I'm going to stick with the 4 over 3, and so then I end up with 4 times pi divided by 3. Okay, so notice in the calculator we just ignored the pi. Then when we get our fraction, we just put the pi in the numerator. Alright, moving on. Okay, here's one. Find the exact value of secant of 315 degrees. And in the past I've told you guys, don't lose your unit circles because you'll be able to use them. So if you have your unit circle, you can use the x and y coordinates for this. So our x coordinate is square root of 2 over 2, and our y coordinate is negative square root of 2 over 2. And hopefully you guys remember that with secant, your secant of theta, let me draw my little theta symbol, is the ratio of, let's see, your radius, which is 1 for the unit circle, divided by your x value, right? Secant is the reciprocal of cosine. So your ratio is going to be 1 divided by x. So if you only have the unit circle, you would take your x value, the square root of 2 over 2, and you would put it in a denominator. Okay, so you'd have 1 over square root of 2 over 2. And hopefully everybody's saying keep, flip, change. Let me move this unit circle over, back out of my way. So yes, you have to do the keep, flip, change. So you'll keep the numerator, flip the denominator, and you get this answer because 1 times 2 over the square root of 2 is just 2 times the square root of 2. And hopefully everybody knows that you cannot leave the radical in the denominator. So whatever my denominator radical is, I'm just going to have that radical in the numerator, and I'm going to multiply by this fraction, which essentially most of you realize you're multiplying by 1. So, and when you multiply fractions, you multiply straight across. So in my numerator, I'm going to have 2 times the square root of 2. And then in the denominator, square root of 2 times the square root of 2 is just 2. So I get a fraction like this, and then the 2's will cancel out. My final answer will just be the square root of 2. Okay, now that's if all you have access to is your unit circle. What if you have your trig table? So hopefully everybody's trig table looks similar to this, where you have your shaded in sections with the inverse functions. We did that yesterday. If we have our trig table and I'm looking for a secant of 315 degrees, I'm going to go down my degree column to 315, and let me draw a line to it. So I have 315 degrees here. Then I'm going to go over to my secant value, and my answer is just going to be the square root of 2. Okay, just like my answer from here. So I can get my answer from my unit circle or my trig table. Unit circle, you have to do all this extra work. Trig table, you just look at the trig table. You're done in like 5 seconds flat. All right, moving on. Next one, find the exact value of cosecant of 4 pi over 3. Kind of the exact same thing that we did last time. If we use our unit circle, okay, notice we're dealing with radians now. So 4 pi over 3 is right here. And cosecant is, hopefully you guys remember that cosecant is, hold on, cosecant theta is going to be the fraction of your radius, which is 1, with the unit circle, over your y value, because it's the reciprocal of sine. So 1 over your y value there. And at 4 pi over 3, my y value is negative square root of 3 over 2. Okay, so we would set up our fraction with 1 over negative square root of 3 over 2. Keep flip change. You do this. Okay, and then you get that, and you have to multiply by the square root of 3 over the square root of 3, and then your final answer is covered up by my unit circle. Its final answer is negative 2 times the square root of 3 over 3. Okay, and then again, let me get rid of all this stuff. If you have your trig table out, it's super easy. You don't have to do all this extra work. You can just go to find cosecant, and let's see, 4 pi over 3. Let me move this bring to front. All right, so let's see, 4 pi over 3 is right here. Go over to the cosecant column, and we get negative 2 times the square root of 3 over 3, which is the same answer that we had right here. All right, now here's another example of a question that we can have. Find the exact value of tangent theta, given that sine theta is 5 over 9, and the terminal side of theta is in quadrant 2. Okay, so with this one, it will help if you draw a diagram of the situation. Okay, so if I have the ratio 5 over 9, remember that sine theta is your y value divided by your r value. Okay, so 5 is my y value, 9 is my hypotenuse, and I need to figure out what my x value is. Okay, so I know that my y value is 5, and I know that r is 9. I've got that figured out. Then I can use my Pythagorean theorem, a squared plus b squared equals c squared, or in this case, x squared plus y squared equals r squared. Okay, and so I'm going to use my 5 and my 9 and my x into the equation so I can solve for x eventually. And to do that, I'm going to subtract both sides by 5 squared, which gives me 81 minus 25. Now, so x squared is going to be 56. So then x is going to equal the square root of 56. Most of you are like, hey, I think we can reduce that. You're right. Square root of 56 is the same thing as 4 times 14, or excuse me, the square root of 4 times square root of 14. Okay, the square root of 4 becomes 2. The square root of 14 cannot be reduced, so it just stays there. So for x, this is your answer. However, don't forget that we are in quadrant 2. So my x value is negative in quadrant 2. So my x value is actually negative 2 times the square root of 14. Okay? So now I know my y value, my r value, and my x value. I'm ready to figure out what tangent theta is. Okay? And hopefully you guys remember that the ratio for tangent is y over x. Okay? So I'm taking my y value, dividing it by my x value, right? And however, I cannot leave the radical in the denominator, so I'm going to multiply by the square root of 14 over the square root of 14. Now my numerator just becomes negative 5 times the square root of 14. Notice how the negative sign started down here and then it moved up here. It really doesn't matter where you put the negative sign, as long as it's somewhere. All right, and then square root of 14 times the square root of 14 is just 14, and 2 times 14 is 28. Okay, so this would be my answer for my tangent theta. All right, now look at this one. We have, given that secant theta is the square root of 11 over 8, we want to find cosine theta. Okay, and I could do the same, go through the same process that we did with this one, where I draw a picture, find my y, my r, and my x value, and then find my ratio. However, if you remember that secant theta is a reciprocal of cosine, then you can do a shortcut. You can just say, hey, to find cosine theta, I'm just going to do 1 divided by whatever secant theta is. So this is my secant theta. And so I'm going to do 1 divided by square root of 11 over 8. Do the whole keep, flip, change thing. Okay. Then you're going to have to get rid of your radical in the denominator. And then you get your final answer. Okay. So guys, you will have one problem where you have this type of information situation where you're given 2 of the values. You have to find the missing value, and then you have to figure out the new tangent ratio based on your 3 values, your x, y, and r, and your quadrant. You'll have one question like that. You also have a question like this, where all you're given is one function, and you have to find its reciprocal trig ratio. Okay, so don't forget your trig ratios and your reciprocal functions and pairs. All right, moving on. This is something we studied at the very beginning of the year, where we found the arc length and sector area of a shape of a circle. So if I had a circle, okay, and let's draw a picture on this one. I probably should have done it earlier, but that's okay. So I have a circle, and okay, let's see, my radius is 50, and my angle is going to be 198, so maybe like that. So my angle here is 198 degrees. Almost looks like a frowny face. Okay. And I need to find my arc length. So my arc length is going to go from this point here all the way around to this point here. So basically, if I took a string, I could run it along this and then measure the length of my string. But we don't have string, and this picture is not drawn to scale very well because our radius is supposed to be 50 centimeters, and most of you can see that that radius is not to scale. All right, so that's kind of what we're looking at. So the first thing we need to find is our arc length, and then we need to find the sector area. But remember, hopefully you guys remember the formulas for arc length and sector area. These are the formulas. If you guys are filling out an index card, you might want to write them down. Okay, so to find the arc length, we need our radius and then times our angle in radians. So this 198 degrees, I've got to convert it to radians. So I'm going to take 198, multiply it by pi, divide by 180. Okay, and then I can reduce my fraction to 11 pi over 10. Or some of you will probably just plug it into the calculator and you'll get approximately 3.456. Okay? Either one is okay as long as you use 11 pi over 10 in the actual equations. So now for the arc length, we're going to do just my radius, which is 50, times 11 pi over 10, and we'll get, it says round to the nearest tenth for our answers. So in this case, I will go ahead and plug everything into the calculator, and I get 172.8 centimeters. And now that's for the arc length, the distance around here. Now I want to find this sector area. And for this sector area, we want to know how much, what our area is in this little shaded in area. See if I can shade it in. Very good. Awesome. I am so good at this. Actually, I think it's the program that makes it so good. So I need to know this little area right here. My formula is going to be 1/2 times radius squared times my angle in theta, or angle in degrees. Oh my goodness. Angle in radians. Don't forget. The theta has to be in radians in this case. All right, so 1/2 times my radius squared times 11 pi over 10. And I'm going to plug all that into the calculator, and my calculator will give me 4,319.7, and I forgot my centimeters squared because it's an area, so it should be centimeters squared. All right, so hopefully you guys remember those formulas, and you're ready to move on. With this one, we're looking at our angular and linear velocity. Hopefully you remember those formulas. And I will tell you, all these weird numbers is really big numbers. I had my youngest son and daughter were just picking numbers randomly. So hopefully you're not going to have any numbers this big on the test, but no matter what, you have your calculator, so it should be easy to do. All right, so we have a pulley is turned at 543 revolutions per minute around an object 78 centimeters away. They want us to find the angular velocity in radians per second, and they want us to find the linear velocity in centimeters per second around the nearest tenth. Okay, so for the formula for your angular velocity is, well, you really don't have one, but if you're given revolutions per minute, you need to take whatever your revolutions are per minute and multiply it by 2 pi, because that's how many radians are in one complete revolution. So in 1 minute, I'm going to have 543 revolutions times 2 pi radians, because there's 2 pi radians in one complete revolution. Okay, but then notice my angular velocity needs to be in radians per second, and my revolutions are given in per minute. So then I'm going to have to convert from minutes to seconds. And in 1 minute, I have 60 seconds. Okay, and then I plug all this into my calculator. And basically, I'm taking this and dividing by 60, and I get this answer. Okay, and then if it's a multiple choice test, and I have no idea what this is what the rounded answer is. Let me see. 100 and, what did we say? 181? 181 times pi divided by 10. All right, so 181 times pi divided by 10. Let's plug it in. Okay, so the rounded answer would be approximately 56.9. Okay, so let me do it this way. Rounded answer, 56.9. Okay, so let's say it's a multiple choice test, and you plugged everything in the calculator and got 56.9 radians per second, but that wasn't one of your answer choices. Hopefully you can figure out, just ignore the pi. Do 543 times 2 divided by 60. Ignore the pi. You'll get 181 divided by 10. Then you can put the pi back in the numerator. Okay? Now, for the linear velocity, I just realized I mislabeled both of these. This should be linear velocity. For your linear velocity, once you find your angular velocity, you're just going to multiply that angular velocity by your radius up here. Okay? So we take our radius, multiply by our angular velocity. Notice I'm not using 56.9 here. I'm using my exact answer. And this time I plug it all in, and I get 4,435.3 centimeters. Okay? Hopefully you guys remember that. Most of you should. Last type of question you're going to see. You have an application problem, and it deals with your sine graph and the transform sine graph. So we have the depth of a river in a city varies depending on the ocean tides. It should sound very familiar to some of the application problems we've looked at. The depth in feet for a given day can be modeled by this function. And you'll have an equation where x is the hour of the day. At midnight, x equals 0. At 1 a.m., x equals 1. 2 a.m., x equals 2, and so on. Okay, so there's 3 different things we need to find with this. The first thing is we need to find our minimum depth of the river. Then we need to know the depth of the river at 9 a.m. is approximately how much, and then at what time will the river is the river approximately 24 feet deep. Okay, so a couple things. Number one, you have an equation. So the first thing that you should do is graph that equation. Okay, so let me pull up my graph. And let me see, I think I already plugged it in up here. Yep. So I plugged the equation in. Make sure it's the right formula. Make sure you have all your parentheses where they need to go. So it should be 14 times sine, open parentheses, close parentheses. Make sure the close parentheses is here instead of over here. Most of my students that had mistakes on the project was just because they put the parentheses in the wrong spot. So check those parentheses. Okay. So once we have that done, go ahead and push enter, and you may not see anything. Okay, some of you really struggle with setting up your windows because you have no idea what window to use. Okay, I'm going to suggest that the very first thing you do after you graph it, go to window, or go to menu, go to windows, and if you come down here to zoom fit, that'll give you at least an idea of what the picture is going to look like. So here's our zoom fit. Okay, this is the window they give us. They do a really good job with the Y values. However, I'm not too impressed with the X values because chances are I don't care what's on the left side of my graph. I just want to see my right side of the graph. Okay, and this problem, let's look at it again. We have the number of hours in a day, and most of us know that there are 24 hours in a day. So I will probably want my my X window. Let me see if I can even see what this, oh, it's probably going to be 10. I probably want my X max to be like 24 hours. Okay, so let's go ahead. Now that I have this picture, I can go ahead and tweak my window settings to fit a little bit better. So go to menu, windows, and then window settings. I don't care about the negative side, so I'm just going to start at -1. And let's go to 24 hours. A scale of 1, or you really could do a scale of 2 if you wanted to. If I'm close to 0 for my Y minute, or to the X axis, I'm going to go ahead and use 0 for my Y minimum. And I always want to go a little bit higher, so let's use 45 for my Y max, and a scale of 5. Sounds good to me, right? Sounds good to you. All right. So now I get a better picture of my graph. Okay. So let's go ahead and start answering the questions. I have it graphed. I can look back at the calculator anytime I want to. Let me move my calculator over a bit. There we go. Now it'll be easier to pull it up. All right. So now the first question is, what's the minimum depth of the river? And notice these are not multiple choice. These are fill in the blanks. On your test, this type of question is going to be a fill in the blank one. So make sure you know how to do this. And for my problem, to find my minimum value, I know my sign's going to go up and down like this. And most of you know you can just analyze your graph and find the minimum point, right? Well, you can do that, but what you could also do is you take your D value and subtract your A value from it. So 16 minus 14 will tell you where your minimum value is. Okay? Let me put it in there. All right, so 26 minus 14, that's 12, right? Let's see, so yep, 12 feet. So the minimum river, or the minimum depth of the river is 12 feet deep. And then I want to know what is the depth of the river at 9 a.m. Couple ways I can do this. I can plug in a 9 for x and just solve for my value. Or if I already have it graphed, I can pull up my table, Control T, go down to 9 a.m. Remember your hours, 0 is midnight, 1 is 1 a.m., 2 is 2 a.m., and so on. So at 9 a.m., the depth of the water is approximately 36.9 feet deep. And so on the test, you are going to have some answer choices to pick from. And so I just picked the answer choice that was closest to 36.9 feet. So maybe if my answer choice was 36 or 37, hopefully you guys all realize that 37 is closer. And so I would pick the 37 feet. All right, last one, we want to know what time. The river is approximately 24 feet deep. And this one is a little bit problematic. Two ways that you can do it. You can set the whole equation equal to 24 and you can solve for x, which can be really hard to do. Or let's go ahead and get rid of our table. Okay, we want to know when is the river 24 feet deep. So let's just push the tab button and we're going to type in 24 here. And I get this line. Now notice I'm going to be 24 feet deep right here, and right here. Okay, and I can just analyze my graphs, find the intersecting point, do lower bound and upper bound. Okay, so I have this answer. I might want to do it again just to find my other answers. And nope, that's not what I want to do. Menu, analyze, intersection, and my last one. Okay, so these are the 3 times that I'm going to be at 24 feet deep during the day. Okay, so which one should I use? First of all, you are going to have you're going to have some answer choices to choose from. It's not going to be the standard multiple choice, but you'll have like 6 or 7 different choices to pick from, and you just need to pick the right one. Okay, so with this one, notice that to help us figure out which one to use, we have the AM here. Okay, so that tells us that we need to pick one of our values in the morning, and we can either pick 11.3 or we can pick 3.68. We need to decide, okay, which one are we going to pick? We're not going to pick 17.7 because that's in the afternoon. We want to pick something that's less than a 12, okay, because 12 is noon. Okay, so right here, some of you might be saying, okay, what time is 3.68? Well, 3.68, your hour is 3 hours, so it's going to be 3 a.m. And then the 6.8 is the 0.68 portion of an hour. So to do that, or to figure out how many minutes that is, you're just going to do 0.68 times 60, because there's 60 minutes in an hour, and you get 40.8. So we can say that one of our answer choices is 3:41. We got 40.8, right? So 3:41 a.m. That would be one of our answer choices. And the other answer choice, let me look. Let's go back to our graph. Nope, that's not what I want. 11.3. So let's calculate what 30% or 0.3 of 60 minutes is. Hopefully you guys are understanding. I'm just taking my decimal and multiplying it by the number of minutes in an hour, and that's 18 minutes. So then I have 1 at 3:41 a.m. I'm going to be at 24 feet deep, and at 11, I totally blanked on the minute, 11:18. So at 11:18, I'm also going to be at 24 feet deep. Now it comes down to looking at the answer choices that I have and picking one that is the closest to my answer. Okay, so in this case, one of my answer choices was 3:41 a.m., so that's the one I'm going to pick. If you don't see 3:41, if you saw 11:18, then you would pick 11:18. Okay, so you are going to have more than one time that you are at 24 feet deep or whatever depth that you want. First thing you need to look at is if it says AM, then you need to pick the one in the morning. If it says PM, you need to pick the one in the afternoon. If you have 2 of them in the morning or 2 of them in the afternoon, figure out what the times are for both and see which one is your answer choice. All right, I think that's the last thing we're going over. Yep, that's the last thing. All right, hopefully you guys are remembering all these things, and I will see you Friday morning. Bye.